Hey guys, I hope you are well. Welcome to College Netted Engineering with Bongani Gumede. So today we'll be doing sequences, and we're going to do sequence 1 on this video. I know most of you say sequence is hard, it's tough, but it's not actually hard. It just need you to understand the statement. Once you understand the statement, you'll be able to draw it and wire it also. So understanding the statement is very important. So your statement says, Motor 2 cannot be started before Motor 1. So in other words, it means that for you to start Motor 2, you need to start Motor 1 first. As long as Motor 1 is not running, this one will never run. So the second statement, the second part of the sequence 1 says that if Motor 1 is stopped, then Motor 2 stop also. So in other words, when this motor is stopped, both motors must stop. But the third part says M2 can stop on its own. So you can stop motor 2 while motor 1 continues to run. So motor 1 is not affected by motor 2, but motor 2 is affected by motor 1. So it means that we don't have a problem on motor 1, but we have a problem in motor 2. So this is your main circuit. I've already drawn the motor circuit, the main circuit, and you have your MCB, you have your first contactor, second contactor, overload 1, overload 2, motor 1, motor 2 connected in star. So that's it. You can just pause the video and look at how the main circuit is. It's actually simple. Everyone knows how to draw it. It's like a direct line, and you just add another one. So that's it about the main circuit. The tricky part is just the control circuit. If you get the control circuit wrong, then everything else will be wrong. You have your line here, and then you'll have your 95, 96 of overload 1. Overload 1. And then you have another 95, 96 of overload 2. And then you have your emergency stop button. Remember, another statement says that, another part of the same statement says that emergency stop, it stops everything. So when the emergency stop button is pressed, everything must stop. And then, remember we said that there is nothing wrong with motor 1. The left-hand side will be motor 1 and the right-hand side will be motor 2. So because of there's nothing wrong with it, we'll draw exactly direct online. If you know your direct online. For direct online, you have a stop, and then you'll have your start button. And then you have is normally open of K1, which means contactor 1 in other words. You can use R1, as long as it corresponds. And then after, you'll come to your coil. It's going to be K1, A1, A2, and then it will go to neutral or to a line. So this is for motor 1. You can see motor 1. But motor 2, remember, we said that motor 2 cannot be started before motor 1. So it means that the first thing that we can do is just to draw another DOL. Let's just draw another direct line. You stop. Stop 1. And you stop 2. And then now the start button. A1, A2, K2. So this side is for motor 2, this side is for motor 1. Normally open of K2. 13, 14, 13, 14, 3 and 4, 3 and 4. So there's something that we have to understand. Motor 2 cannot be, this is actually direct online. But remember, there's something wrong with motor 2. It has to be dependent on motor 1. So I'm going to come to that. This is our normal direct online. If you watch the video of direct online, you'll know how it operates. Go and watch the video of direct online. So they say that this motor cannot be started before motor 1 starts. So if this motor is not running, you press the start button. Current will be able to flow, energize the coil and motor run. But now, for us to make motor 2 dependent on motor 1, we have to put a normally open. A normally open of contactor 1 of K1. Remember I said you can use any alphabet. You can use C1, C2, but I love to use K because it's the most commonly used. So we add the normally open of contactor 1. So in other words, when this motor, when this coil K1 is energized, the motor will run. Remember, when the coil energizes, every contact of contactor 1 has to either be normally open or normally closed. So they change their state. So before a contactor, when it's not energized, its contacts, if they are normally closed, after being energized, they must be normally open. So because of here it's normally open, immediately when the coil is energized, this normal open will become a normally closed. So you'll be able to start motor 2. So that is why we put a normal open, to say that when this motor, when motor 1 is not running, also here there will be an open link which will cause motor 2 not to run. So as long as motor 1 is not running, this one will not close, this contact will not close, this normal open. So that's what it do. And then the emergency stop, when you press it, it will stop the whole circuit from operating. So that's it about the sequence 1. You just have to understand that immediately when you put a normal open, when the coil is energized, everything that falls on contactor 1, it has to change its position, either normally closed or normally open. So what I'm trying to say is that if you have a contactor and its coil becomes energized, each and every contact of a contactor, it will change its position. In other words, normally open will become normally closed, and normally closed will become a normally open. That is why we added a normally open on motor 2. We added a normally open, so that when this one is energized, this one can close, so that this one can run. So that's it about sequence 1. It was not tough, very easy. As long as you understand the statement, then you'll be able to apply it there. Yeah, that's it. Thank you. Let's meet on the next video. Chap chap.